Lesson 10.6 is on parallel and intersecting lines. So we look like we have lines that are parallel to each other, and then a line intersects. And lots of interesting things happen when you have this situation. A linear pair are two angles that are adjacent to each other that form a straight line. And it almost goes without saying that since they make a straight line, the measures of their angles has to add up to 180 degrees. So if we have this angle and then another angle adjacent to it, which by our definition of adjacent means they have to share the side and a vertex. And if together they make 180 degrees, then you have a linear pair. And there'll be lots of kind of problems to solve where you might say you're given that this is a linear pair and this angle measures 61 degrees. And you have to figure out the measure of angle x, which you do by saying 180 minus 61. Should give us 119 degrees for angle x. Vertical angles are sometimes called opposite angles. Easy to see because in the definition they are defined as opposite angles formed at the intersection of two lines, and they are congruent. So if I have one line here and then another line that intersects it, the opposite angles would be this angle and this angle, and also this angle and this angle. So if I call this angle 1 and this angle 3, angle 1 is congruent to angle 3, and if this is angle 4 and angle 2 is congruent to angle 4. So if I knew the measure of any one of these angles, like if I knew that this was a 110 degree angle, angle 3, I would know that these are a linear pair. First of all, angle 2 and angle 3 are a linear pair, which makes angle 2 70, because they have to add up to 180, which makes angle 4 70, because they're vertical angles. And since angle 1 and angle 3 are vertical angles, they have to have the same measure. So once you're given one piece of information and you know your theorems, this is a lot of the kind of problem solving you'll be doing in this chapter, that give in one piece of information, fill in a whole bunch of stuff based on the one thing that you knew. Alternate interior angles are formed when you have a set of parallel lines, or two parallel lines, and then another line that crosses over them. And this pink line is called a transversal. So the two white lines are parallel, and the pink line is called a transversal. The interior angles are all the angles that are inside, these four angles that are all inside or between the two parallel lines. Alternate means opposite sides. So I'm going to go ahead and label these four inside angles. I'll call this angle 1, angle 2, angle 3, and angle 4. So if I wanted to determine what is the alternate interior angle that goes along with angle 4, first of all, it has to be in between the two parallel lines because it's interior, meaning inside, and it has to be on the opposite side of the transversal. So if angle 4 is on the right-hand side, the alternate interior angle has to be between here and has to be on the left-hand side. So it can't be angle 2 because that's on the same side. And it's also they're going to be alternate in that one's going to be sort of in the bottom, the other's going to be in the top, which eliminates angle 3 and only leaves angle 1. Now, the cool thing about alternate interior angles is they're congruent to each other. So if I know angle 4 was 70 degrees, I know angle 1 is also 70 degrees. I don't have much room to write that. Let me pick a different color, just show up a little bit better. So that's 70 degrees. This would be 70 degrees. If I know angle 4 is 70 degrees, and I know angle 3 and angle 4 together make a linear pair, that makes this a 110 degree angle. And then angle 2 up here would have to be the same size as angle 3 because they're alternate interior angles, so it's also 110 degrees. Then I can also tell that this is a 70 degree angle because they're a linear pair, and this must be a 110 because they're a linear pair, the 70 and the 110. And I could match up this 70 here with this angle, which means because they're supplementary or they're a linear pair, that's a 110, and this must be a 70 because it's a linear pair with a 110 degree angle. So once you have this parallel lines and a transversal, if you know any one of these 8 angles, 1, 2, 3, 4, 5, 6, 7, 8, if you know any one of those 8 angles, you can determine the measure of the other 7. Corresponding angles are a pair of angles in matching positions that are formed when a transversal intersects 2 parallel lines. So assume that the 2 white lines are parallel. They're the 2 parallel lines, and the pink line is the transversal. So we have some corresponding angles that are formed here, angles that are in matching positions. And it's kind of easy to show if I move the bottom line up to the top line, you'll see which angles match up with each other. So I'm still maintaining that they're parallel to each other, or trying to. And you can see that angle 1 and angle 3 have the same size, and angle 2 and angle 4 have the same size. It doesn't matter. As long as I keep them parallel, then they still match up. Keep it parallel there, kind of tilting a little bit. So because they are corresponding, they're congruent to each other. That's what corresponding angles are. Corresponding angles are congruent. So they're in matching positions. That's what we're saying, that angle 1 is above this parallel line, this line, it's parallel to this line, and angle 3 is above it. They're on the same side of the transversal. That's important. So they're at the same side of the transversal, and they're both above the line. So angle 1 corresponds to angle 3. They have the same measure. Angle 2 corresponds to angle 4. So if I label angle, call this angle 5, then its corresponding angle would be down here, angle 6. So angle 5 and angle 6 correspond. And if you look at them, you can tell they appear to be the same size. Now, it's not good enough just to look at a diagram and say they appear to be the same size. You have to have a theorem that tells you they are. And you could say, I know that angle 5 and angle 6 are congruent because they're corresponding angles. So again, if you knew that this was a 50-degree angle here, you would have proof that angle 6 is also a 50-degree angle. And once you knew that, you would know that this is a 130-degree angle, because 130 and 50 make 180, etc. So there's lots you can do with that. We get alternate exterior angles the same way we get alternate interior angles when we have parallel lines and a transversal that crosses them. Where the interior angles were inside or between the 2 parallel lines, the exterior angles are on the outside, both below and above the parallel line. So those are the 4 exterior angles. If I call this angle 1 and designate this as angle 2, those are matching exterior angles. One is below the parallel line and one is above the other parallel line, and they're on the opposite sides. And this theorem tells us that angle 1 is congruent to angle 2. So if angle 1 is 50 degrees, angle 2 is 50 degrees. And then angle 4 and angle 3 would also be alternate exterior angles. So think about exteriors on the outside and alternate, one's above, one's below, and one's on the left side and one's on the right side. That's how they're alternate exterior angles, and the big idea is that they are congruent to each other.